How's that halfway for you to tell me how to fix it? You always have ideas. Sweet. Okay. Ready. We're not taking a day off. We have this week, so we're doing the last lesson today. Tomorrow we'll do like AP practice problems from this unit. Wednesday is practice test, Thursday is test. And we have like 2+ weeks to do practice test review. That's the plan. I'll wait for chat. Watch Mr. Shit keeps it on there for 20 minutes.
What's your favorite old language?
English.
No. Hey, you guys called it
Okay. This is from like algebra, advanced algebra. Exponential growth and decay. So just a quick review of that. That's your initial amount. So that means when t equals 0. And the reason for that is if I put a 0 there, put a 0 in for t, what's anything to the 0 power? It's 1, and then a times 1 would be a. B is your growth or decay rate. If you are growing, it's 1 plus some percentage. If you are decaying, it's 1 minus some percentage. And then the t is time. So the reason I'm showing you that is because all of these problems are going to end up as exponential growth and decay. Basically, they give you the derivative or the differential equation version of it, and then we'll go from there. So if I look at part A, or number 1 here. The weight of an animal is increasing at a rate proportional to its weight. So the weight is increasing, tells me dW over dt. If it just says proportional to, that's multiply, right? Because if it wanted to divide, what word would it use? Division would be 1, it could use, yeah. But, so there's directly and inversely. So if they don't tell you directly or inversely, it's implied that it's direct. So it's k times something. If it were inverse, it would be k divided by something. But this is dW over dt, so the weight is increasing proportional to its weight. So at this point, if I were you, I'd be like, well, why the hell did you just show me this? And then you told me this. Those don't seem related. They are. That's one of the points I want to make. So let's separate the variables on this like we did this Thursday and integrate it and see what we end up with. So if I put everything, if I put like all my W's on the same side, I would have dW over W equals K times dt. And basically what I'm trying to do is integrate it and show you that it ends up there. So this would be like W to the negative first times dW. Good way to rewrite it first. And then we'd integrate both sides. So what's the integral of W to the negative first? Ln of the absolute value of W. And then over there, that's a constant. And you're integrating with respect to t. So kt would be your integral. If I took the derivative of kt, I would end up with k. So I get that. And then I would do e to both sides. So those go away. I just get w equals e to the kt plus c. But then we kind of finagled that into a different way to use a constant, if you remember. So we said you can write that as e to the kt times e to the c, because remember, if you were to combine those like, in the other direction, what would you do with those two exponents? You'd add them together, right? So I'm just separating that. And then we said, well, that's just a constant. So w is going to equal c times e to the kt. So that A is the C. The B is that constant e to the k, and then the t is the t. And the idea that they're trying to get across in this lesson is you can jump from one to the other without doing all the steps in between. It's very common that they'll give you one like this. So I did one to kind of show you what they want you to do. I'll set up a differential equation. So the bacteria population is shrinking at a rate proportional. So the population is shrinking, so that means it's changing. So that means derivative. Proportional to, so that's directly proportional, so that's k times its population size, which in this case would be p. So if I were to do all that stuff, like do the separate the variables and integrate and all that, what I'm going to end up with is P equals C e to the kt. So you can do it, or you can just kind of remember that shortcut. So do that one. I don't know why there's not a number there. Oh, no. It actually literally tells you the answer, like very directly in the box below where you're working. Yeah. So you check your work. So the same idea. This would end up being y equals some constant times e to the kt. So when you see this, that's going to be exponential growth. Which is going to be that setup. And if you forget that, it's not going to cost you, it's going to cost you time. Doesn't mean you'll necessarily get it wrong, but you would have to like do the stuff we did there, separate the variables, integrate, and set that up. But this is just kind of a shortcut. Alright, so if I look at 4, now they are giving me enough information to find a little bit more. So I'm going to do number 3 like a longer way. I'm sorry, number 3. We've done 4 problems. 3 problems. Whatever. I'm going to do this one the normal way, and then we'll kind of shortcut that one. You're good. 2 issues here that I can shortcut. One is just like, can I just jump to this right away? Or should I go through that whole process again and show you? Is that okay if I just jump? But I'm not done. What's K? K is 6. Because it's like dy over dt equals k times y, so that k is that 6. And then they're telling me to find, basically you're trying to find c. They give you mean y equals 5 and t equals 0. So I can plug in, but here's what's going to happen. 5 equals c times e to the 6 times 0. I'm trying to solve for c. But 6 times 0 is 0. And then what's e to the 0 power? It's just 1. So doesn't this just say 5 equals c? Which makes sense because back in the notes up there, what I said was that number is the initial amount. So you can really jump to right there. Try 4. Yeah, you did see this.
Yeah.
How did you know you were supposed to? Scratch you. Okay, so general form, I could do this. That's my general form, but then I know the number in front of the y is my k. That's going to be -3. And I know that's my initial amount. So if you want to plug in 0 and 4 and kind of prove it to yourself, great, but I would just do that. that alright for 4? Who's celebrating over here? Good work. Carter was celebrating? You have a question? What do you got? What?
Yeah, it would be X in this case.
Oh, because of that? Okay, yeah, that's fair. No, it's fine. I'm wrong like this every day. I'm just not used to Carter being the one that yells at me. Oh, fine. Maybe you should yell at me more. Usually I turn around and Will just has a look on his face. Number 5. So, a little bit different here. You got to do some work to find out what K is, and then plug something in. You guys have done similar stuff in advanced algebra. It's been a while, but this is basically a point 0, 3, like 3 pounds at birth, and then 4 pounds 3 months later. So 4 pounds 3 months later. The weight of the animal is increasing. That's a rate, so that's dW over dt at a rate, so that's the rate. Proportional to, that means directly proportional, so k times. And then we've got W. So again, this is where you get to like, do I want to separate these and like go through it, or am I comfortable just saying W is going to equal CE to the KT power? And I don't have an initial weight this time. Oh, no, I do. Yeah, so what's that C? 3. Okay? But I gotta find out, it's like 5 comma 1. So I used that just to set up my equation. This I'm going to use to find W. So I'm going to plug in 3 for T, 4 for W. Did I say to find W? Find K. We're going to try to find K. So 4 is W. And then T is 3. So that'd be 3K. Or K times 3.
How come you can't just do y2 minus, or
Because it's not linear. That works for growth, like that goes up, but we're an exponential. So I gotta solve this for K. So I would probably divide both sides by 3 first. So I'd have 4/3 equals e to the 3K. And then how do I get that K downstairs? Natural log both sides. So I'll have the natural log of 4/3 equals 3K. So then K will equal the natural log of 4/3 divided by 3. I kind of got to know what that is, so let's type that in. You know how I said like round to 3 decimal places? Do that at the end. Like, while you're working, so I got 0.095894022. I'm going to keep that as many decimals as I can. If I can just do it from that, I want to. When I get to the end, I'll round my answers. So if you start rounding them away, you're kind of a little off, and then you get a little more off. It's not ideal. So I'm writing down a whole bunch of decimals. I think that's probably good, because then there's a 0, 2, 4. But I'm not done. What I know now is my actual equation. Is W equals 3e to that, to the 0.0958940T. So a second ago we had W equals 3e to the KT. We just went through and found K. And now I want to know how much the animal weighs when it's 5 months old, so where do I put that 5? Put it in for T. So you just go in 3 times e to the, I would do like second answer. times 5, because then it just keeps the previous thing in there, you know. Previous answer times 5. So now I can round because I'm done. So 4, 8, 4, 6. Question on that anywhere? Yeah. Because it says it was 4 pounds 3 months later. So this is like time and then weight. It said when they were born it was 3 pounds. So like birth and then the weight. And then at 5 months, what was the weight? That answer? What else? Anything else? Alright, so got 6. So population is going to double every 7 years. They'll put half-life questions here too. Population gets cut in half every whatever years. That's also exponential. What's the value of k? So I can start off by going, well, I know y equals some constant times e to the kt. But then I don't know an initial value, so I'm a little bit stuck. I can fix it, but I don't know like what number to start with. But let's say I wanted to start with 10. There's 10 people. If it's doubling in 7 years, how many people will there be in 7 years? Someone like multiply 10 times 2. Jeez. I'm blaming you, Warren. You're not talking. So if I divide both sides by 10, I end up with that. Fair enough? Well, let's say I made my initial amount $1 million. What would go here? 2 million. And when you divide it, what would you end up with there? 2. I made this 35. That's 70. When I divide it, it's 2. So the initial amount doesn't really matter. You just need to know that when you do the initial amount, the end amount divided by the initial amount, you get 2. If it was a half-life problem, what would you put here? You put 1/2. If I want to know when things quadruple, I would put a 4. The starting amount doesn't matter. So, doubles every 7 years. I gotta find the value of k. So I know 2 equals e to the k times 7 power. This is just saying it takes 7 years to double. And then I can solve this for k. So first of all, does the setup make sense? Then I can solve, so take the ln of both sides. So 2 equals 7k. So ln of 2 equals 7k. Divided by 7. And I get that, or if multiple choice makes it decimal, question on anything in there? You're not doing. There's 2 of them. You can skip 9 and 10. I don't need 9. What I would do, what I would suggest, is you do 7, 8 homework, and then if you turn the page, there's a chapter review. I think you turn the page right after 7, 8, there's a chapter review, right? So, like to me, I'm assigning both of those. 7, 8, and review. Tomorrow we'll do more review, but in the form of AP questions. Wednesday we'll do more review, but in the form of like an actual practice test. Yes, sir. Yeah, no, that's fine. No, that's fine. Or smaller. You're welcome to use smaller. Yeah, you can chop it in half. What? Okay. For like an easier class. It works on Khan, I guess. I saw someone take a picture of Khan.
Well, that's because all those are already.
But that was like regular geometry. So. It's not like, why did I so confused by Quizlet?
I said some of them.
All of them.
What you guys are telling me right now is you're writing the test. You're not doing your homework and you're not reviewing. So I could have it ready by tomorrow. Definitely don't need 2 reviews.